Hello geometry students, please put your name, date, and period. Today we're learning lesson 4-2, isosceles and equilateral triangles. Your objective is that students will be able to use properties and theorems about isosceles and equilateral triangles to solve problems. You will identify congruent triangles using properties of isosceles and equilateral triangles. Okay, and if you have a highlighter, you can highlight this section, explore and reason, or you can just put an asterisk like this, a little star. Explore and reason. Understand angles of isosceles triangles. So we're going to be looking at angles. The figure below shows a triangle with two sides of equal length. Trace the triangle. So you're going to get some tracing paper and you're going to trace this triangle. And as you're tracing it, I want you to label this angle A, this angle B, and this angle C. So that way you can see what's happening. For part A, it says, in how many different ways can you flip, slide, or turn the original triangle so that it fits exactly on the outline? So now that you've traced your triangle, try to slide it. Can you slide it onto itself? No, it just stays there, right? Can you flip it onto itself? Can you rotate it? Like, can you turn it so that it will end up onto itself? So the only thing you can do is flip it. And when you flip it, you get this same triangle on top of itself. And the B comes over to this side, the A comes over here, and the C comes over here. So there is exactly one way to flip. And I'm going to put that in quotations because the correct word we use is reflection. There's exactly one way to flip the triangle. Part B says to look for relationships. Relationship. What does that mean? Well, how are things related to each other? How do the angles and sides of the outline correspond to the angles and sides of the original triangle? Well, angle A is congruent to angle B, right? Because they line up on each other. And sides, and we show that with a line on top of the letters, sides, not AB, but AC, are congruent to each other. So side AC is congruent to BC. And we should probably write angles over here. So you get used to that symbol for angle. And the symbol for side is the line on top of the AC and the line on top of the BC. How would your answer to part A change if all three sides of the triangle were equal in length? So that means we would have a triangle like this. Oh, well, that's not perfect, but all three sides are equal, and so you could flip it, probably flip it on that side, and that side. So you could flip it three ways. And you could rotate it 1, two ways, I think. So you could turn it or rotate it two ways. And now we have a theorem. And for this theorem, if you have a highlighter, I want you to highlight, or if you don't have a highlighter, just put an asterisk. For this theorem, isosceles triangle theorem and the converse. So we have a theorem about isosceles triangles. Remember that isosceles triangles have the same, or they have two sides that are the same in measure. If two sides of a triangle are congruent, then angles opposite those sides are congruent. Okay, so if these two sides are congruent, then the opposite angles are congruent. So the opposite angle would be over here, and that angle would measure this angle because that would be opposite of that side. If the two angles are congruent, this is the converse, if the two angles of a triangle are congruent, then the sides opposite those angles are congruent. So this side would be congruent to this side. Okay? So that's showing that these two sides are congruent because of the angles being congruent. And that is the isosceles triangle theorem and the converse. Okay, so turn the page. Example 2. We're going to use the isosceles triangle theorem. So again, if you don't have a highlighter, then put an asterisk here. An architect is designing a community park between North 1st Street and South 1st Street. The pathways on either side of the pool will be equal in length and will provide effective access and circulation around the pool. So the pool is, I'm going to get blue highlighter. The pool is right here. To protect the landscaping and to minimize erosion, the architect will place a triangular section of triangular cobblestones at the corners along Park Plaza. So here's Park Plaza, and we have these two angles of that triangle right here. What angle measure should the architect specify for the corners in her design? Well, they give us this angle right here that's 50. Right, so that's angle D is 50. What we're going to do here is we're going to say that angle D plus angle E plus angle F equal how many degrees are in a triangle? That's right, 180 degrees. So if we know that angle D is, I'm going to write 50 right here because we know it's 50 degrees, then what do E and F have to be? Well, we would take 180 degrees and we would minus 50. That gives us, try and do that in your head or on your paper, 130 degrees. Well, that means that E plus F equals 130. And we know that it's an isosceles triangle because, well, they told us in the word problem, but they also show these little tick marks right here. And those tick marks, see that, shows that North 1st and South 1st Street are equal in measure. So E and F, those angles have to also be equal in measure because of the isosceles triangle theorem. So if angle E equals angle F and angle E plus angle F have to equal 130 degrees, then what we're going to do is divide 130 by 2 to figure out each angle. So 130 divided by 2 is equal to 65. Right, so 65 plus 65, that gives us 130. Yes, so angle E is equal to 65 degrees, and so is angle F. So that is our final answer for the swimming pool problem. The cobblestones are going to measure 65 degrees in those two corners. Let's do some try it problems, and I want you to follow along, and then you will try it 2B on your own or with a partner. What is the value of x? So we have these two angles equal to each other. So negative 4x plus 9, that angle is equal to 8x minus 3 degrees. We need to solve for x. So our steps for solving is that we want to get variables on one side. I'm going to subtract the 8x to remove it from the right side. And I'm going to subtract it from the other x. So this cancels. We are left with a negative 4x minus 8x. Think about the number line. We're at negative 4 and we're subtracting 8, so it's going to get more negative. It's going to be negative 12x plus 9 equals negative 3. The next step, this is a two-step equation, which means we're going to subtract and then we're going to divide. So subtract 9, subtract 9. This cancels. I'm going to bring my equation up here. And the negative 3 minus 9. Think about the number line. We're at negative 3, and we're going to go back 9 more. So it's going to become more negative. It's going to equal negative 12. And so I also need to bring my negative 12x with it. We're going to divide both sides by negative 12. This cancels. So now we have x equals, what's negative 12 divided by negative 12? If you said 1, you're right. And that's it. It asked us, what is the value of x? X equals 1. If they asked us, what is the value, or what is the measure of the angle, then we would have to plug that 1 into this x. So 8 times x is 8, and 8 minus 3 is 5. You could also plug it into this x, and negative 4 times 1 is negative 4. Negative 4 plus 9 is also 5, which is kind of weird. Like, I don't think that's really 5 degrees, but okay. So if you want to write 5 degrees right here, you can. But that wasn't the question. The question asked what was x. So try it on your own, and we'll be walking around to help you.